Hi dear students, we are starting a new chapter, that's probability, and we are going to study about mutually exclusive outcomes. What is mutually exclusive outcomes? Here it is the definition. When a coin thrown, it can land either head or tail, it says. You know that one, it cannot happen, both outcomes cannot occur at the same time. So this means the sentence here cannot occur at the same time means mutually exclusive outcomes. And you remember the outcomes means experiment results of our mathematical experiments. And when you toss the coin, and here you are going to see that there are going to be two possible results. One of them is head and one of them is tail, and you are going to see that also both of them cannot shown at the same time. So the second example that I'm going to give here about the rolling the dice, and I open one dice here. You know what is dice, and it shows 6 sides, and each number here, each point represent one side. So here there are 1, 2 here, 3 points and 4 points. So this is 3, this is 4, and 5 and 6 it's going to be. When we fold this one, we are going to get something here, and the top part, what shows that number is the value of the rolling dice experiment. If you want, also I can show here. Now when I roll the die, it shows 1. When I roll it again, it shows 4. When I roll it again, 1. Then 2 it showed, as you see here. It's going to be like this. Okay, we are rolling the dice, and there are two things that happens, and we are going to try to understand these are mutually exclusive or not. The case A and the event A. This is the event A and event B. We have here, this is the event A and event B, and they are mutually exclusive or not. We are going to try to understand that one. Okay, we are rolling the die, and it shows us 6. This is the case A. We are rolling the die, and it shows us 3. So this cannot happen together. When you roll the die, if it is 6 and if it is 3, this cannot be. It shows 3 or 6. So these are mutually exclusive events. But the second one is not. Let me explain why. When you roll the die, it shows 2, and when you roll the die, it shows even number. So it means that it shows 2, 4, and 6. It means that here, these two, they are intersecting. This can happen together. Where number can be 2 and number can be even also. So this is not mutually exclusive event. It's going to be. Okay, let's continue with the sum of the mutual exclusive outcomes. Actually, the sum of the probabilities here, when you roll the dice, there are 6 possible, I said. So the probability of event, it's going to get value with respect to this number. Totally possible outcomes means that one here. If you roll the dice, if there are 6 possible cases, it means that your total possible outcomes is 6, as you see here. All of them, they are 6. To get the value is 1. To get 1 is 1 of the value, and it's equal to 1 over 6. So the probability, it's going to be 1 over 6. To get 2, it's going to be 1 over 6. To get 3, it's 1 over 6. To get 4, it's going to be 1 over 6. To get 5, 1 over 6. And it's going to continue like that. Or you can do like this. To get less than 3. So when you say to get less than 3, there are two possible cases. This is 2 and 1, and all possible cases, all possible is 1, 2, 3, 4, 5, and 6. It's going to be here in this set. There are 6 elements. In this set there are 2 elements, so the probability of the event, it's going to be equal to 2 over 6 here. Or to get prime number, you remember the numbers divisible by 1 and only itself, so 2, 3, and 5 it's going to be. So there are 3 numbers here, and all the possible cases, it's going to be 1, 2, 3, 4, 5, and 6. So there are 6 numbers here. Then the probability of prime, when you roll the dice, it's going to be 3 over 6. I didn't simplify this one, but it's going to be equal to 1 over 2, and here 1 over 3 also it can be. Okay, so here we are understanding that the probability of the mutually exclusive outcomes also gives us 1. So here, when you roll the dice, totally 6 possible cases there are. When you add them, 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6. Here I'm counting 1 over 6, 1 over 6, 1 over 6. Totally 6 times I need to write, and one of them, this is the last one. Okay, you know, when the bases are same, it's going to be equal to 1 plus 1 plus 1 plus 1, which is equal to 6. 6 over 6, it's going to be equal to 1. So the sum of the probability of all, it's going to be equal to all mutually exclusive events. It's going to be equal to 1 all. Let's say probability of everything, it's going to be equal to 1 always. We need to remember that one. Okay, here we will try to understand this one with this one also. Now there is a spinner and hexagonal figure. There is these all equal triangles. I mean the angles are equal, so that's why hexagonal figure has chosen. So here there are 2 boxes, 2 triangles for red, 3 blue triangles there, and 1 right triangle. So if you try to understand the probability of red, probability of white, and probability of blue, I can write like this. Since there are 6 totally, 6 triangles, 4, 5, and 6, all of them, they are going to have the denominator 6, because all possible cases are 6. How many reds there are? 1, 2. So the probability of red, it's going to be 2 over 6, which is equal to 1 over 3 also. What is the probability of white? There is only 1 white triangle, so it's equal to 1 over 6. And what is the probability of blue? There are 3 blue triangles, so it's equal to 3 over 6. And at the end, again, when you add the 2 over 6 plus 1 over 6, and 3 over 6, it's going to be equal to 6 over 6, which is equal to 1 again. So sum of all possible mutual events is going to be equal to 1. All possible mutual events. Okay. Here there is a question about mutual exclusive events, all possible outcomes. Adrian has spinner with 4 colors. The table shows the probability of spinning 3 of the colors. So what is the probability of the green? Here we are going to understand this one. Probability of red plus probability of white plus probability of yellow and probability of green, all they are equal to 1. This is the case here. So this is equal to 0.1 plus 0.25 plus 0.4 plus probability of the green, and all the sum is going to be equal to 1. So when you add them here, this is going to be 0.10, this is 0.25, 0.40. So total sum is 0.5, 0.75. So 0.75 plus probability of the green, it's going to be equal to 1. So probability of green is equal to 1 minus 0.75, which is equal to probability of the green. It's going to be equal to 0.25. Going to be. Okay, I'm going to continue with the fourth question, and I'm going to finish here. A bag contains only red, yellow, and orange sweets. The sweet is picked at random from the bag. The table shows the probability of picking each color. So the red is to 0.2, 0.35, and this one, if we say probability of the orange, it's going to be equal to probability of the orange, probability of red plus probability of yellow plus probability of orange. They are all equals to 1. We need to understand this one here again. 0.2 plus 0.35 plus probability of the orange is equal to 1. Here this is 0.55 plus probability of the orange, it's going to be, and it's equal to 1 again. So probability of orange, it's going to be equal to 1 minus 0.55. Probability of the orange, it's going to be equal to 0.45.